Professor Baldwin here, and today we're learning about logarithmic functions and their graphs. A logarithmic function, base 2, would look like this. And it's read the logarithm base 2 of x. And what it means is the power to which we raise 2, or 2 to what power, gives us x. More general, a log with base a would be in this format, y equals log of base a of x, and it translates to x equals a to the power of y. So this is how you can convert between a logarithmic function and exponential form. Key things to remember: log of 1 is equal to 0, and the log base a of a, so when these two are the same, you get 1. If you have a natural log, that's when you have a base e. It can also be simplified and written as ln, or natural log. The natural log of 1, same rule, it equals 0. The natural log of e equals 1. That's because the natural log of e would be log of base e of e. And that follows the same rule up here. Without using a calculator, we're going to evaluate and find the logs of these two examples. Log of base 2 of 16. That's the same as saying 2 to the what equals 16. Well, 2 to the power 4. So x equals 4. Or log base 2 of 16 equals 4. The second example, log base 3 of the fourth root of 3. Well, remember what the fourth root of 3 is. That's the same as saying log base 3 of 3 to the power of 1/4. And we can rewrite this as 3 to the what, right? The base to what power gives us 3 to 1/4. And this would be x equals 1/4, or evaluating log base 3 of the fourth root of 3 is 1/4. Okay, here we're going to convert a couple other logarithmic equations. 10 cubed equals 1,000. This can be written as log base 10 of 1,000 equals 3. The way I convert from an exponent to a log is to draw an L. I start at my base, and then I go to the number that it's equal to, come back to the equal sign, and then the exponent. See how it kind of makes an L? Something else to remember, log of base 10, this is the most common log, so it's written without the base 10. So it can simplify as log of 1,000 equals 3. Now example 2, we have Euler's number e squared equals 7.3891. And if we use that same shortcut to convert it into a log, we would get log base e of 7.3891 equals 2. And because this is a natural log, right, base e, that can be written as ln of 7.3891 equals 2. Now what if we have a log and we need to convert it to exponential form? Well, I have another shortcut for that too. You can write an e. So you start at the base and you come over to the answer and back to what you were taking the log of. And that would tell you there's no base here, so remember it's implied that it's 10. That would be 10 to the power of -2 equals 0.01. Here we start at the a, go to the x, and then what we are taking the base of. See how it kind of looks like an e? That's telling you you're going to an exponent. So a to the power of x equals t cubed. And our last example for this page is using a calculator to find the log and the natural log. This is really important. We need to be comfortable with our calculators. So we'll pull up our calculator. We're going to find the log of 0.57. To do that, you're going to hit log, and then you're going to enter the value, 0.57. You have to close the parentheses, and then you're going to hit enter. And you get the result. That is negative 0.2441. Okay, what about taking the natural log? Let's pull our calculator back up. Natural log, you're looking for ln. It's just below the log here on the left. You'll hit ln. We're taking the natural log of 2. Enter 2 and close the parentheses, then hit enter, and you get 0.6931. So 0.6931. We like those leading zeros. It helps that decimal stand out. Now, what if you don't have a common base? You don't have a base e or a base 10. Then you would use this change of base formula. So here we have log base b of m. We can change it to a base of a. That's any base we choose. And what we were taking the log of goes in the numerator, and what our base initially was, base b, goes in the denominator. That comes in really handy when you need to graph something. So here, we can easily input f of x equals 3x into our calculator. That's y equals 3x. But our calculator can only handle logs of base 10 or natural logs. Here we have a log with base 3. So we need to use that change of base to give us a log of base 10. So we'd have log of x on the top, and on the bottom we have to take log of what our original base was, log 3. Now we can enter both of these into our calculator and graph the function and the inverse function on the same graph. So we'll pull up the calculator. We're going to go to the y equals. Our first graph is 3 to the x, so we're going to put in 3, use the caret key, and then enter our x. Hit enter so we can enter our second. Then we need to do, I like parentheses, log of x for our first, that's our numerator. We need to close the parentheses twice. Divide, and I'm going to do parentheses again, log of 3, and close the parentheses twice. That's our second graph. Now we can hit the graph button, and see it drew both of those functions for us. Okay, our next example. Briefly describe how the graph can be obtained from the graph of a basic logarithmic function. Then graph the function using a graphing calculator. This is why we're practicing. Give the domain and the vertical asymptote of each function. Okay, so what is our basic function here? Well, the basic function would be log base 2 of x. And that's what we started with, and then it added 3 to it. Remember, adding 3, that would be a shift left by 3 units. And we'll see that when we graph it. But how do we graph this? Because it has a base 2. We need to do that change of base. So on the top, we have log of what we were originally taking the log of, and on the bottom we have log of the original base, log 2. We can enter this into our calculator now. We're going to go to the y equals. We want to enter the log of x plus 3 in our numerator, divided by the log of 2 in the denominator. We'll hit enter, and then we can hit graph in order to graph that function. So we've graphed the function. Notice that it is our log base 2 of x shifted to the left 3 units. Now, what do you notice for a vertical asymptote? So what is this vertical line that it's approaching but not getting to? That's x equals -3, right? We know that from this numerator. So your vertical asymptote is going to be when x plus 3 equals 0 or x equals -3. Now going back to our graph, what's our domain? Remember, the domain are the possible x values. Well, the smallest x value we have is right where that vertical asymptote is, -3. And headed to the right, it goes on forever and ever. So our domain is going to be from -3 through infinity. Now, what is the domain of that basic function? The domain of the basic function is going to be from 0 to infinity. And the vertical asymptote, that would be x equals 0. How about a real-world example and a chemistry example? So the pH of a substance is defined by this function. P of H equals -log of H+, where H+ is the hydrogen ion concentration in moles per liter. We need to find the hydrogen ion concentration for each substance and express in scientific notation. Well, look at A. We're told that the pH equals 7. That means 7 equals -log of H+. If we divide by this negative, we would get -7 equals log of H+. And let's put it in the order we're used to seeing it. Log of H+ equals -7. Remember, we can convert this into exponent form. And if we do that, we get 10, that's our base since there's no base listed, to the -7 equals H+. Well, that's scientific notation, so we're done with A. Let's look at B. B says that 4.8 equals -log of H+. Now, we're going to do the same steps that we did for the tap water. We're going to divide by the negative so that we put it over with the 4.8, and we're going to rewrite it in the order we're used to. And I'm going to do that all at once. So log of H+ equals -4.8. And we're going to convert this to an exponent. So 10 to the -4.8 equals H+. Now, this is not scientific notation because scientific notation doesn't have a decimal for an exponent. So what we want to do is we want to come to our calculator and we want to calculate what is 10 to the negative, make sure you're using the negative symbol and not the minus, 4.8. And notice this is 1.58 times 10 to the -5. So it's 1.58 times 10 to the -5. I hope you're feeling a little more comfortable with your calculator and maybe also with logarithmic functions and their graphs. If you have a question or you come across a problem you want help with, leave it in the comments and I'll include it in a video.